Have you ever been in the car, listening to tunes with nowhere to go, and wondered how the radio worked? What those numbers meant? How you could switch from pop to rock and back in a split second? Well, you're in luck. Music, or any sound we hear, is a mechanical wave resulting from vibrations in the medium through which it is transmitted. When you hit a tuning fork, for example, air molecules are compressed together at regular intervals. Electronically, we can then represent this pattern of high and low pressure areas as a sinusoidal wave. We call the height of this wave its amplitude, and one repetition of this pattern a period. 1 over the period is then called the frequency of the wave, denoted by units of 1 over second or Hertz. Music, or any real-world signal, is made up of multiple sinusoids of different frequencies added together. But for now, let's just pretend songs are simple electrical signals like this one. We know that there are dozens of radio stations that all want to transmit different music at the same time. How do we make sure we're only hearing the one station we want instead of a jumble of them all? I'm sure you know. We assign each station its own frequency. But wait a minute. If each station only gets one frequency, and each song also has its own frequency, how can we hear different songs from the same station? There are two ways to solve this problem: frequency modulation and amplitude modulation. Let's talk about AM radio first. We can call our music signal MFT and define it as equal to cosine of 2 pi times the frequency of our song multiplied by time. Now let's add a constant a to it, so our signal is equal to a plus MFT, and that's greater than 0 for all time, which ensures that MFT does not cross the time axis. Let's also define another signal, C of t, at the frequency assigned to our radio station. F sub c, or the frequency assigned to our radio station, is usually greater than F sub m, or the frequency of our music signal. This is because our music signal lives in the audible range of frequencies from about 20 Hz to 17 kHz, and AM radio stations operate on a frequency range from 550 kHz to 1720 kHz. Here's the cool part. To do amplitude modulation, we then multiply the signal C of t by our music signal M of t to get a new signal X of t. It comes out looking like this. Look familiar? You can see that our signal has the frequency of our radio station, but we have also preserved our song. The radio station's frequency is the carrier frequency in the middle, and its amplitude is modulated by the song's frequency. When your radio receives this signal, it just undoes this, and voila, you have your song.
Turn the radio on.
Said another way, AM radio uses the radio station's frequency to carry the song. FM radio also works on a similar principle, where M of t is used to modulate the frequency of C of t instead of its amplitude, like in this case. All this is to say, when you're listening to the radio, you're tuned in to the wonders of engineering. Thanks for watching.